In this lecture, we are going to go over a very new and exciting environment for writing deep learning code in Python, which is Google's Colab, short for Colaboratory. For those of you who like to use Jupyter Notebook, this is an even better option. This is basically the same as Jupyter Notebook with the following bonuses. First, it's hosted by Google, which means you don't have to use your own computing power. You'll notice that when you need to download data files, it happens extremely quickly because, well, Google's network is extremely fast. Second, you get access to a GPU and even Google's new TPU, which is pretty amazing. A TPU is not something you can buy for your personal computer, so it's pretty nice to be able to make use of one. Remember that the way PyTorch code is written, you don't have to worry about what kind of device you're using. Well, for the most part, TPU is another story. But generally speaking, the same code will work, whether you're using a CPU or a GPU. Third, the Colab notebooks are stored in your Google Drive, so it's in the cloud. You'll never lose it, and it's very easy to share with other people. Fourth is that many of the libraries you need for deep learning, machine learning, and data science are already included. In fact, I was surprised that there were many more than I assumed there would be. There are even competing deep learning libraries already included, such as Theano and PyTorch. So for those of you who hate doing environment setup, myself included, this is really truly awesome. So in this lecture, we're not going to do anything really technically complicated. Rather, we're just going to talk about Google Colab and do some short demos so you know how it works and can see for yourself that it's just like writing Python anywhere else. To start, I'm going to assume you already know how to create a Google Drive account. If you don't have one, go to drive.google.com and sign up. Once you have your Google Drive account and you've logged in, you'll see this interface. From here, you can hit the New menu, which allows you to create all different kinds of files, such as Google Docs, a spreadsheet, a presentation, and so forth. So let's do this. So now what you want to do is go to the More menu and hit Colaboratory. All right, so as you can see, this brings up a new notebook, and from here, you can mostly use this as you would a normal notebook. Now, one thing that might happen to you is that you might not see Colaboratory in the menu at all. So as you can see, I've hit the New menu and I've hit More, but I don't see Colab. In this case, here's what you can do. You want to select Connect More Apps. From here, just search for Colab, and the first thing that will pop up is Google's Colab. Add this, and Google Colab will become available from the menu we just looked at. So if we go there again, we can see that Colab now appears where it should. So let's go in and rename this notebook to TF 2.0 Intro. So first we're going to get right to the good stuff. How can we make use of a GPU or TPU? In order to do this, you'll want to go to the Runtime menu and select Change Runtime Type. As you can see, there are two select boxes here. The first one lets you select which Python version you want to use. So we'll be using Python 3 for this course. The second lets you select what kind of device you want to use. So that's either none, which is the default, or GPU or TPU. Now note that sometimes the GPU or TPU might not be available. This is because these are shared resources. So your fellow peers taking this course and other machine learning students and researchers all around the world might be using Google Colab. And we are all sharing these resources. So if our usage of these resources hits the limit of what's available, then you might not have a GPU or TPU available when you need them. For this reason, some of the code you'll see in this course may be done on my local machine as well, But remember, Python code works the same anywhere, so it does not make a difference. Next, you can see that there are two main types of cells that we can create in the notebook, code and text. You can click on either of these to create a new cell of that type. Let's click on text, since that's a little easier, and it's not really something we are going to use very often, so let's just get it out of the way. So I'm actually going to delete the very first cell. All right, so as you can see, when I click this, it creates a new cell with what looks like a rich text editor. You'll notice that it's split in two halves. The left half is where you enter your text, and the right half is a preview of what it will look like. So let's enter some text. This is my title. Now you can click the little t, big T icon, which changes it into header text. So you can see that it makes this a little bigger and bolder, appropriate for a title. Next, let's enter some regular text. This is regular text. Now note that there are also these arrow brackets. So it looks like it's going to let us enter code snippets. So let's try that. And so as you can see, it makes the text a monospace font, which is appropriate for code. Now there are some other options here. So you can make a link, you can add images, you can indent, you can add a numbered or bullet list, and so forth. So if you're interested, play around with this. Otherwise, we're not going to mention it again. Next, we have the code cell. So let's create one of those. All right, and as mentioned, we're not going to write any fancy code in this lecture. We just want to do something simple to make sure everything works as expected. So let's start by importing NumPy and Matplotlib. All right, beautiful. As I mentioned earlier, these already come pre-installed. Next, let's create a new code cell and make a sine wave. So first we need to create some x values. So let's make x go from 0 to 10 pi with 1,000 points in between. Next, let's make y the sine of x. Next, let's create a new cell and plot what we just created. So that's just plt.plot xy. Now, since this is a notebook, there's no need to call plt.show, since the plot will just appear in the notebook itself. All right, very cool. Works just like a regular notebook. At this point, we've convinced ourselves that Google Colab can do the usual things you'd expect from a Jupyter notebook. Now, as I mentioned earlier, one thing that's very nice about Colab is that it already comes with a bunch of useful libraries pre-installed. In my opinion, this makes Google Colab way better than Jupyter Notebook, and if anyone ever asked me to write in a notebook environment, I would choose Colab by default. I'm not a big fan of Notebook, but I am a big fan of Colab. So here we can see that I've written some code to try and import a bunch of libraries. Specifically, these libraries are libraries that have been used in my courses, some more than others. Some are pretty rarely used, so you might not expect that they would be included, libraries like WordCloud, which we've only used once so far. And yet, if we look, we see that everything I've tried to import here does not throw an error. So this tells us that these libraries are indeed available. What's interesting to me is that some of these libraries are not machine learning related at all. Of course, we've used them in my courses because they are generally useful as Python libraries, but it's nice to see the folks at Google also make use of these same libraries, and so thought to include them. So here you can see the usual stuff such as scikit-learn, NumPy, SciPy, Matplotlib, and Pandas. We also have Torch and Theano, which is surprising because they are competing deep learning libraries, and development for Theano has been stopped for a while now. We also have Seaborn, WordCloud, Beautiful Soup, which is for XML and HTML parsing, Requests, which is for making HTTP calls, NetworkX, which is for graph functionality, CV2, which is for OpenCV, and Gym, which is OpenAI Gym. All in all, very impressive and much more than I expected. So there's some final caveats to Colab that I want to mention. First, the main thing you have to remember is that this is the cloud, so these are shared resources. So one way this affects you is if you leave your notebook alone for a long time, it'll become inactive and disconnect. Any computation that you may have run earlier won't be saved. So for example, if you define a variable a equals 5, and then you come back later after your notebook was disconnected, and you try to print a, it'll say a is not defined. So you see this notebook has disconnected. So let's say I do reconnect and I print a. It's going to say a is not defined. Another way this affects you is that you might run out of memory. So if that happens, you might want to try running the code on your local machine instead. And as mentioned earlier, the GPU and TPU might be unavailable. So either you can run your code without the GPU or TPU, or you can run the same code locally. As always, options you had previously are still available. For example, you can provision a GPU instance on AWS, which if you choose the correct AMI, or Amazon Machine Instance, will come with the usual libraries pre-installed also.